For this example, my hope is that you try it out on your own first, and then you start watching this video to try to see if you can get yourself unstuck or just to check your answers, right? So periodically throughout the video, I'll ask you or I'll give you a chance to pause the video so that you can see if you can try to generate the next step or maybe finish the problem altogether, okay? So let's get started. So we'll read the problem, right? So we have a food vendor has 16 food carts roaming the city of Hayward. Okay? On average, each food cart sells 240 food items. Okay, so they sell something. So some of my favorite things are mangoes, maybe corn, paletas, something like that. Okay, so the food vendor can add more food carts, okay, but every new food cart reduces the average output of each cart by 8 food items. Okay, so how many new food carts should the vendor add in order to sell the highest number of food items? Okay, so I went ahead and drew a picture here. So these little lines here, so there's 16 of them, right? 4 by 4. So there's 16 little lines. Those are our original 16 food carts. Okay, so on average, right, approximately, on average, each one of these will generate 240 food items sold, right? So some form of food, okay? So this problem is saying that the food vendor can add more carts, right? So they have the capability of adding more food carts, okay? So maybe they add like 1 or 2 more, right? So let's say they add 1 more. So you can add more, right? But then what it does is it creates kind of a subtraction in the average number of items sold per cart. So for each new food cart that I add, I'm actually subtracting 8 from the sales of everybody altogether, right? So if there are more food carts in the city, then individually each cart sells a little bit less, right? So the idea is every time I add a new cart, I subtract 8 from the average sales of each individual cart, right? So if I add 1 cart, I subtract 8. If I add another cart, then I subtract another 8 from the average, right? And so on. Okay, so at some point, I don't want to just throw 200 food carts on here and then have each food cart sell, maybe 1 or 2 items, right? I want to find a way of writing down how many food carts I need in order to sell the most amount of food items. Okay, so that's what the problem is asking. So I went ahead and declared a couple of variables. So you can see X here is the number of food carts added, right? So how many carts do we add on top of the original 16? And then F is the number of food items sold, right? So that's the thing that we want to maximize, right? So the last two examples have been about minimizing something. This is now about maximizing the number of food items that we sell, okay? Because we're looking for what is the number of carts that will yield the highest number of food items sold, okay? So that's what F is going to be, right? So F is going to come into play in our equation that we want to optimize. Okay, so let's actually try to write that down, right? So that's actually the next step in solving these optimization problems. So essentially here we've done steps 1 and 2, right? We read the problem, we read it again and really thought about it and drew a picture and labeled some variables that we're going to use. Okay, so step 3 is write down the equation that we want to optimize. So we want to optimize. And by optimize, I actually mean maximize, right? We want to find a maximum. The equation F, right? So the number of food items sold. So let's try to generate an equation for this. Okay, so if you think about how many food items are being sold, so it's going to be, so I'm going to write this in words here, right? So it's going to be the number of carts, right? So how many carts do you have on the street? Maybe, so potentially it's going to be a little bit more than 16. So each cart, right? So that's how many carts. And then a number of food items, so times the number of food items sold by each cart. And here, one assumption that we're making is that each cart sells roughly the same amount, right? So there's no one like big time baller cart that sells a bunch, like 1,000 items, and then everybody else sells like 10, right? So they're all performing at relatively the same level, and they're all selling around 240 items. Okay, so that's the assumption that we're making here, right? So that's why it says on average, right? So on average, each food cart sells 240 food items. Okay, so if we write down an equation for the number of food items sold, it should be the number of carts on the street times the number of food items sold by each cart. Okay, so now take a second, pause the video, and try to write down what these quantities should be using the variables that we have up here, right? And what's stated in the problem. Okay, so hopefully you took a chance to pause the video and didn't just sit with me in the silence here for like half a second. But here we go, right? So let's keep going. So the number of carts, right? So if we're trying to write down an equation or an expression for the number of carts on the street, well, we started with 16, right? That was the original number. And then potentially we're adding a couple of carts more, right? And that's really this variable x that we declared here, right? The number of carts added. So it's going to be 16 plus however many carts that we added, right? So 16 plus x. Okay. So then we need the number of food items sold by each cart, right? So that's going to be the original amount, right? So originally it was 240, but we're actually losing 8 food items on average for every cart that we add, right? So we're losing 8 items for every cart that we add, right? So for every cart that we add means we're multiplying this by x, right? So if you look up here in our example, I added 2 new carts and that subtracted 8 2 times, right? And if I included another cart in here, it would subtract another multiple of 8 there, right? So 3 new carts means subtracting 3 8s from 240, right? So you can see here I added x, so I'm subtracting 8 x times. Okay, so that's where I get this equation from. So I get this, right? This is my f. We want to maximize this, right? So we want to make this as big as possible. Okay, so what we're going to do here is we're going to go ahead and distribute everything out, right? So that we can take its derivative a little easier. You could actually probably take its derivative right now, but you'd have to use the product rule, right? And if you can avoid using the product rule by doing a little bit of algebra, then why not? Okay, so let's go ahead and distribute this out, right? So this is f equals, so if I multiply this all through, so 16 times 240, that's 3840. Okay. Then I do the outside terms, so 16 times minus 8x, that's going to give me minus 128x. Okay. Then the inside terms are going to give me plus 240x, and the outside will give me minus 8x squared. Okay, so let's go ahead and put together those terms with x's on them. So we have 3840. Then these two terms in the middle are going to give me plus 112x. And then I still have this minus 8x squared. Okay? So if you think about this, this right here is the equation of a parabola, right? And if you think about the shape of that parabola, it should really be a parabola facing down, right? Because of this minus 8 out on front here. Okay. So this is the shape of a parabola, which means it should have a maximum, right? And its maximum should happen right here at the vertex. So when we're looking for the maximum of this function, really we're looking for what is the vertex of that parabola. Okay, so in the next step, when we take its derivative, we should actually keep in mind that what we're going to be finding is the vertex of this parabola. Okay, but we can find the maximum of this function by taking the derivative, set it equal to 0, and then seeing what x value we get, and that's the x value that goes with this peak, right, this vertex. Okay, so let's go ahead and take the derivative of this function, right, so we'll do that on the next page here. Okay, so capital F, let's just rewrite it so we know what it was. We remind ourselves of what it was. So it was 3840 plus 112x minus 8x squared. Okay. So here again, I'll give you a second to pause the video. And so take the derivative of this function, set it equal to 0 and solve for x and see what x value you get, right? And if you can finish the problem from there, then go ahead. But take a second and try to work that out. Okay, so welcome back. So let's try to take the derivative here. Okay, so taking the derivative, so I like to write down what the step is that we're doing, right? So take the derivative. Okay, so we're going to get f prime of x equals, okay, so derivative of 3840, well, that's a constant, so that should be 0, right? So I won't write anything down. Okay, so the next term is derivative of 112x. Well, that's a constant times x, so the derivative should just be 112. Okay. The next term is this minus 8x squared. Okay, so the minus 8 is just going to hang out there, and we differentiate x squared. And for that, we get 2x. And I'll go ahead and simplify this a little bit. So 112 minus, so 8 times 2 is 16x. Okay. The next step is setting this equal to 0 and solving, right? So we're going to do 112 minus 16x equals 0. So this is going to give me x equals minus 112 over minus 16. And if you punch that into a calculator, that is exactly 7. Okay, so x equals 7. Okay, so if we think about what we just found, this number is giving me the number of carts that I need to add in order to maximize the number of food items that we sell, right? So that's what the setup was, okay? So this x, this 7, is giving me the solution that I want, right? So then the food vendor should add 7 carts in order to maximize profit. So maybe instead of maximize profit, I'll say maximize the number of food items sold. Okay, so that's our solution, right? So once again, like I said, maybe in the previous video, the solution to this isn't necessarily this calculation or this number, it's really this sentence, right? So when you write down solutions to these problems, you should give me a concluding sentence, okay? So this is what the solution to the problem is rather than these calculations that are up here. Okay, so this concluding sentence. Now you try the next problem, right? So I gave you a picture to work with, so go at it.